So we have to show that the second derivative of y with respect to x, that's given by negative 1 over a, and first derivative of y with respect to x as a1 at theta equals to pi over 4. To do that, we are given x equals to a times 2 theta minus sine 2 theta, and y equals to a times 1 minus cosine of 2 theta. So here x and y are provided in the parametric form. So let's begin. So we have x is given by a times 2 theta minus sine 2 theta. What we'll do? Let's take the derivative on both sides with respect to theta. So a here is a constant, so we'll keep it aside. We'll simply multiply it to the derivative of 2 theta minus sine 2 theta. That gives us a times, so here 2 is a constant, so we have 2 times derivative with respect to theta of theta minus derivative with respect to theta of sine 2 theta. So this is a multiplied to 2 times, we have derivative of theta with respect to theta, so that's 1, minus derivative of the sine function is cosine of 2 theta, multiplied to derivative with respect to theta of 2 theta. All we have done is use the chain rule. So that gives us a multiplied to 2 minus, so from derivative of 2 theta will give us 2. So we have 2 times cosine of 2 theta. Now we will use y, which is equals to a times 1 minus cosine of 2 theta. So let's take the derivative on both sides with respect to theta. So this will be equals to a multiplied to derivative with respect to theta of 1 minus derivative with respect to theta of cosine 2 theta. So this will give us a times, so derivative of 1 being a constant, so that's simply 0. We have negative of, now derivative of cosine function, that is negative sine theta, so we have positive sine 2 theta. Then again we need to use the chain rule and multiply it to derivative of 2 theta with respect to theta. So we have a times sine 2 theta times derivative of 2 theta with respect to theta, so that simply equals to 2. So we have 2a times sine 2 theta. So this is the value of dy over d theta, derivative of y with respect to theta, and derivative of x with respect to theta. So that's given by, so here we can take 2 as the common factor. So 2a multiplied to 1 minus cosine of 2 theta. Fine. Now what we'll do, we will find out dy over dx. So that can be obtained by first taking derivative of y with respect to theta and dividing it with derivative of x with respect to theta. So we have 2a divided 2a times sine of 2 theta divided by 2a multiplied to 1 minus cosine of 2 theta. Right. So here 2a and 2a gets cancelled. So this gives us the value of dy over dx, which will be equals to sine 2 theta divided by 1 minus cosine of 2 theta. We can further simplify this because we have few identities, trigonometric identities. So let's state them out. So sine 2 theta, so this can be expressed as 2 times of sine theta times cosine theta. And cosine of 2 theta, so that's given by 1 minus 2 sine squared theta, which means 2 times sine squared theta is going to be equals to 1 minus cosine of 2 theta. So we will use these two values to rewrite dy over dx. So dy over dx, so that will be equals to, so in place of sine 2 theta, we have 2 times sine theta times cosine of theta divided by, so we have 1 minus cosine of 2 theta, so that becomes 2 times sine squared theta. So here this will reduce to cosine of theta divided by sine of theta, and this ratio is simply the cotangent of theta. So we have obtained that dy over dx, so that's equals to cotangent of theta. Fine. Now we can we can find the value of dy over dx at theta equals to pi over 4. All we have to do is replace the value of theta with pi over 4 such that we have cotangent of pi over 4 and this value is equals to 1. Right. And this was what we were asked to prove, that So first derivative of y with respect to x, so that's equals to 1. Now we'll find out the second derivative of y with respect to x, so that should be equals to negative 1 over a at theta equals to pi over 4. So let's do that. So we'll start with dy over dx. So we will take the derivative on both sides with respect to x. So we have derivative with respect to x of dy over dx equals to derivative with respect to x of cotangent of theta. On the left hand side, we have second derivative of y with respect to x, and on the right hand side, derivative of the cotangent function. That will give us negative cosecant squared theta. But since we have theta, we have to multiply it to derivative with respect to x of theta. Now, we have dx over d theta, which we have obtained. We have the value of dx over d theta. From here, we can obtain the value of d theta over dx. So here, d theta over dx will be simply the reciprocal, which is 1 over 2a multiplied to 1 minus cosine of 2 theta. Fine. So let's use this. So we have negative cosec squared theta. So this will be divided by 2a times 1 minus cosine 2 theta. Fine. So what we'll do now, we have the second derivative of y with respect to x. All we have to do is find out the value at theta equals to pi over 4. So second derivative of y with respect to x calculated at theta equals to pi over 4. So this will be equals to negative cosec squared pi over 4 divided by 2 times a multiplied to 1 minus cosec. So here we have 2 times pi over 4, which is pi over 2. So cosine of pi over 2, that's 0. So that means we have, and we also have to find out the value of cosec pi over 4. So cosec pi over 4, that's square root of 2. So we have square root of 2 whole squared divided by 2a multiplied to 1 minus 0. So square root of 2, so that's simply 2. So we have negative 2 divided by 2a, and 2 and 2 gets cancelled, but leaves us with negative 1 over a. So here we have showed that the second derivative of y with respect to x calculated at theta equals to pi over 4. So this value is equals to 1 over a. And we have already obtained that the value of first derivative of y with respect to x calculated at theta equals to pi over 4. So that's equals to positive 1. Hence, proved.